Hello everyone, my name is Xing Hao. Today I'm going to show you my newly designed 3D printed robotics arm MK5. I designed and built this in this summer, and so this robotic arm has 5 degrees of freedom, and they all use stepper motor with gear head to drive the joint. And so I have another one inside of this, inside the base. And as you can see, this is actually what they call slew bearing. So the inside is so the outside is fixed by my stand off, and the inside can drive. You can see that, okay. And inside of this base is actually another stepper motor, okay. And I have, in addition, I also have many limit switches to control the position, record their final position, and actually initial position. And you can also see 2 switches at here. And I actually have a stepper motor inside of this cylinder in order to control the rotation in about this axis. And I have a small NEMA 8 stepper motor on the end, at the end, as the final end effector direction. Not actually as the final end effector. I don't really know what should I put here. Maybe I can figure it out later. Anyway, this robot is built only for research. It's not really designed to carry some load or do some fancy movement. But I designed this so it's relatively small and convenient, and maybe I can just put on my desk and start putting code in it. I designed this also for the inverse and forward kinematics research, which will be very important in the later experiment. So here is a MK5 robot, and you can see I print all the parts by that Prusa printer, and you can see right now I don't have power, so the stepper motor are not locked. Stepper motors are not locked. So I use Arduino at here, but it's only a device that controls the stepper motor's motion. In fact, all the angle calculation, angle calculations are calculated in this in MATLAB. And I wrote a serial communication between MATLAB and Arduino. Because if you want to do like matrix and all those Jacobian matrices and like those trigonometry, inverse kinematics, it's not really good to just do it on Arduino. So you better to use a math heavy software like MATLAB. Okay, so I'm going to show you how to use MATLAB to control this robotic arm. Okay, and so I have called the Arduino connection open. This actually open the serial, open the COM port for Arduino Mega, and so basically send the ladder and wait for Arduino to reply. Okay, yep. It's just a character. And if I Okay, let me clear the history first. So if I make this a serial class, so it will give me serial communication setup, and I click OK, so it's connected. There's a class called TT. Serial class is created. It was created, and now I need to turn on the. Arduino is already connected. I have all my limit switches, all the code for limit switches and the stepper motor. They actually stepper motor actually uses stepper motor actually use they use what's that called, the acceleration stepper. This library, it's very convenient to use, and they have a lot of class and object you can use. And so I have oh, forgot to turn this on. So the fan is on, and okay, and okay, actually let me. All right, so previously I wrote a code that can send two characters into Arduino. First character is H, means homing. So two steps. First is homing, to make the robotic arm go to a horizontal position. So that's the initial position. And then I have another letter called M here, which is move. So after entering the letter M, character M, X, Y, Z values will be inputted into this MATLAB program, and I have a subfunction that posing the X, Y, Z value and output theta 1, 2, 3, which is the joint variable rotational angle. And here are all the inverse kinematic equations I calculated. If you can see here, I've done some old school geometry. So law of sine, law of cosine. The goal is to get those theta angles by knowing that I have the X and Y and the Z, the initial Z values. So that's what eventually come out, those equations. And I also have another part of program that can generate a 3D plot, a 3D graph of a simulated robotic arm. I will show you later. It can be a good reference for my actual robot. Right now I'm going to run this program, and it will ask me please enter the command, and I want to home it first. Okay, and it starts to home. It will go to once it hit the limit switch, it will stop. The motors will stop. You can see it slowly goes to that limit switch. Okay, and then it will go to a horizontal position. Alright, so homing is complete, and the program, actually I need to run again for moving. Alright, so please enter the command below. So I want to uppercase M. Okay, and now it asks me to put in the coordinate. So X I want 300 millimeter, Y I want 300 millimeter. Oh, by the way, I only figure out three three joint variables here, which is the base motor, this one, and the motor at here. I kind of want to figure out the this motor and this end effector, but I don't really have time. I will put another video once I finish all 5 degrees of freedom to do the inverse kinematics. Right now it's only 3. Okay, sorry. I'll go back. So Z is the height. Maybe I give like a 400 millimeter. Okay. And I'll move slowly to the position. Okay. Alright. Seems it's got to its position. Oh, I also have a graph that can show the position of my my robot arm. So it's just a line in plus 3D, and so this is a base and first arm, and the offset, and the second long arm, and you can see this is like this kind of angle, so it's kind of similar. I don't have an accurate measurement of I don't have a measurement for the actual position right now, but it looks legit. I mean, if I go to the top, so okay, so this is X and Y, so maybe, yeah, maybe, I'm not sure. Maybe I can measure it later using ruler. Okay, and you can home it again actually. So I can say maybe I can just move to another position. Okay, I want to move to another position. So maybe last time is 300, so that's 45 degree on XY coordinate. So maybe right now I want the 100, 400, let's give 350. Oh, okay. I'm not sure. Hold on. This cracked? Looks like I have some mistake here. Sorry. Yeah, that's probably because the in my Arduino I forgot to set the current position as 0. No, I set the current position as 0. Okay, so so the problem is it's still seeing the original position. It's still seeing actually it thought that the previous position, which is 300, 300, and 400, is the new position. So in fact, my coordinate should should refer to the horizontal position in the beginning. So I will change that. But anyway, I mean the graph should be right. Yeah, always trust this graph. And anyway, I'm just going to home it. So I hit home. Okay, it's going back. Yep, it's kind of slow actually. Okay, so it goes back to the horizontal position. Yeah, so that's what I have done so far. Yeah, it still needs a lot of improvement. Right now I can see I can only home it and then go to one position and home it again. But the ideal situation should be I home it only once and then I keep giving it some coordinates and will keep moving to those coordinates. So, and another thing is because I use the geometry method, sometimes I need to turn this off. Ow. Yeah, I mean that's also another problem. Another thing is, so if I go to robot test, so that's so this program robot test is a program that only calculate the angle without communicating the Arduino. So the problem here is if I have a negative number, if I have negative 200, negative like 300, and for 400, so this should give me the final position at the third quadrant on XY coordinate. But just see what the robotic arm can become. Oh shit, sorry. But see what happened. I think that's because doesn't give any solution because my angle is negative, and I just don't like the geometry method to solve inverse kinematic. I should use an analytical method. I don't know. Yeah, I mean I still need to update this video. Anyway, thank you guys. This is hella project to do. It's a very big project to do, and but the key thing is that I figure out how to communicate how to send the data from MATLAB to Arduino, and that can actually help me a lot later. So I can just focus on. I can just keep focusing on the inverse kinematic calculation, and if I think I got it, I can just prove it by sending the crack program to the Arduino. Actually, by writing the crack program on MATLAB and send it to Arduino. So thank you guys.